Hi, welcome to video 5 in the differentiation topic. We're going to look at something called Leibniz Notation in this video. So very quick success criteria here. We're going to be able to use Leibniz Notation when differentiating. So instead of differentiating expressions that start f of x equals, we're going to start differentiating expressions that start y equals and other letters equals. Okay, and nothing else is changing. Okay, should be a very quick video just going through a couple of examples with different notation. Okay, so when using y equals or equivalent instead of functional notation, so that's f of x, we write the derivative as dy by dx, where it's in terms of x, instead of that f dash x. So looking at this one here, we've got find the derivative of y equals all this. So normally we would have f of x equals, and then we do f dash. Instead, this time we're going to do dy with respect to x, so dy by dx, and then just differentiate as normal. So 5 comes down, multiplies by the 3 to give 15x to the power 4. Then it's minus 24x squared plus 6. Okay, and that's it. Nothing else is changing here, just the different notation. Okay, if the y equals is not y equals and the x's are the x's of the different letters, it would just be exactly the same thing, dp by dq, for instance. Okay, but that's just how you show differentiation in Leibniz notation. Okay, so for an example of that, actually, if you want to differentiate s is equal to 5p cubed minus 6p with respect to p, the differential is going to be ds over dp, ds by dp. So we're differentiating s with respect to the p's. Okay, and then we would just differentiate as normal. So 3 comes down, that becomes 15p squared minus 6. Okay, and nothing else is changing. That's the kind of key thing here. Okay, so in this one here, when we're finding the rate of change of this fraction at t is equal to 5, we're going to do exactly the same processes. It's just the notation is going to be slightly different. Okay, so rate of change again means differentiation. So to differentiate this, we need to rewrite it. Okay, I'm going to put both things on top over t over root t, or t to the power of a half. So it'll be 6t squared over t to the power of a half. Take away 8t over t to the power of a half. Okay, simplifying that, the 6 is just going to be 6. 2 take away a half is just 3 halves. And then 8t divided by t to the power of a half, what's going to be 8, and then t to the power of 1 divided by t to the power of a half is just t to the power of a half. Okay, that's us ready to differentiate. So dy by dt in this case, because it's y equals and it's in terms of t. 3 halves times 6 is 9 t to the power of a half, minus half of 8 is 4 t, and then minus 1 over 2. Okay, so let's just tie that up a little bit before we use it. So dy by dt is equal to 9 root t, take away 4 over root t. Okay, so when t is 5, okay, t is 5, that means dy by dt is going to be 9 root 5, take away 4 over root 5. Okay, which when you do that fraction as a single fraction becomes 41 over root 5. And if you wanted to be really proper, you could rationalise that denominator, so 41 root 5 over 5. Okay, that bit then probably not important. The key thing here is, for this video, is a different way that we can write f dash x. Okay, so again, just looking back at success criteria, only one thing extra we're taking out of this video is that different way of writing the differential. So when you have y equals something in terms of x, you write your differential as dy by dx. Okay, thanks for listening.